Hello, my name is Win Tran, and this is my experiment over at Alka-Seltzer, and I named this title Fizz and Bubbles because of all the effervescent stuff. Okay. Just a little background about Alka-Seltzer. It's a medication that relieves headaches, migraines, and muscular aches and pains. Alka-Seltzer is made of aspirin and sodium bicarbonate, which people mainly do not know. And the reaction that happens when you connect it with water is actually called the effervescence, and it's a series of chemical reactions that break down the Alka-Seltzer tablet. Beardsley came up with this idea after having a conversation with a local newspaper localist, and they talked about the flu, and that's what inspired him to combine the aspirin and sodium bicarbonate, which were helping with the flu. But he died before his idea was able to be flourished and actually became used and became famous. My motivation was basically my sister always got headaches, and people in my family always had headaches, and they always used medications for it. But for Alka-Seltzer, when you put it in water, it dissociates and reacts. So we want to see if she can take it with like juice or water, and what temperature she take it at. And so that's what my motivation was. For some safety, I wore goggles, gloves, lab coats because it was in a lab. I made sure not to touch the hot plate since I was heating up materials, and I made sure to dispose of liquids and let it dry and cool down before I touched it again, just so that everything would be correct. For my design, I had used materials, and it was Alka-Seltzer tablets, 4 beakers, thermometer, stopwatch, water, apple juice, orange juice, hot plate, ice, lab coat, goggles, and gloves. It's just what you need to use to be able to use the lab. The main stuff was just the stopwatch, water, apple juice, orange juice, and hot plate, and ice. My procedure is I filled up beakers up to 100 milliliters at room temperature for 23 degrees Celsius, and then I put the Alka-Seltzer tablet in, and that's when the effervescence started. And so then you have to time it until it fully dissolves, and then you click end. And I did this for 4 trials at each temperature, and I did this at 10, 15, 23, 30, and 40 degrees Celsius. And I also did this to repeat it with apple juice and orange juice afterwards to see the difference. For my results, uh, I had the trials here as well, but I didn't want to show that because it wasn't important. I just want to show you the average at 10 degrees Celsius for water, at 15, 23, 30, and 40. Same thing for the apple juice and orange juice at these temperatures. I also include the standard deviation, and you can tell my standard error is half of my standard deviation because my trials was only 4. So I believe 4 was enough of trials to be used for this experiment since I'm using so many different temperatures. This is my graph. For my experiment, it was a little bit different because the effervescence for the apple juice and orange juice was different than the water, because when you put the Alka-Seltzer inside the apple juice and orange juice, it started foaming up on top of the actual effervescence, so it was hard to see when it finished. So I measured it differently, which I'll explain in the next slide. And this is the temperatures and how long it took for each one. For the t-test of the water, I compared the t-test of the water from temperature to temperature because I was more accurately able to describe when the effervescence was stopped. And so from different temperatures from 10 to 15, I did from 10 to 23, all of them, and the t-values were extremely high, which meant that the p-value was extremely low. And so 9 out of 10 of them had p-values which were less than 0.003, which meant that it did not happen by chance, and that it was over 99.997% significant. I didn't want to get the exact p-value because it's so high that it wouldn't even change from this amount anyways. However, there was one that had a p-value that was significant. From 23 degrees Celsius to 30 degrees Celsius, it had a p-value of 0.146, which meant that 14.6% happened by chance, and it was 85.4% significant. Although this is still significant, it was just I wanted to note this because it's different than the other ones. So as I said, since the reactions happen differently, I didn't want to compare water to apple juice and water to orange juice. And so if that was the case, I would be able to do 10 degrees from water to apple juice. But since uh, I was able to record it differently for the apple and orange juice, I decided to take the t-test for the apple and orange juice, comparing those two, and I compared the water with different temperatures. And that also helps with the experiment as follows too. So for the t-test with the apple and orange juice, at 10 degrees it was 17.87, 15 degrees was 9.16, and 23 and so on. And the t-values are extremely high again, which meant that they're all significant and that it had a very low chance that it happened by chance. So, in conclusion from my experiment is that the temperature and the rate at which Alka-Seltzer reacts is significant. Different temperatures affect how fast it reacts and how long it takes to react. There is also a significant difference between the apple juice and the orange juice in the reaction time. So the apple juice, it reacted faster than the orange juice, which meant that it would take a long time for it to sit for the effervescence to stop. And which is strange, but that's what happened in my experiment. And so apple juice reacts faster with Alka-Seltzer than orange juice. And in the end, it should be noted that you should not use Alka-Seltzer with juice and only with water, because I'm not sure how that foaming affects it, but it's not safe at all. Thank you.